Hello folks, welcome to the last video of the polynomials unit. We're going to learn how we multiply and divide polynomials. So to start us off, like we did in the last video, we're going to talk about how we multiply numbers. Maybe some of you do this, maybe some of you don't, but if I asked you to do 3 times 25, for example, some of us know that because money, right? Quarters, 3 quarters is 75 cents, but if we didn't, if I asked you to do this multiplication, a lot of us would take this and say, okay, well, I can do 3 times 20 and 3 times 5, and we could find the answer that way. Well, we could write that out as 3 times 20 plus 5, because that's what 25 is. It's 20 plus 5. And when we do that, we get something that looks like this, right? We can think about it as a picture where I have a rectangle that is 25 squares by 3 squares. And what I can do is I can take that side length that's 25 units long and I can break it up into its 20 unit side and then another 5 unit side. And the reason I might want to do that is because we might not know 3 times 25 off the top of our heads, but most of us could do 3 times 20 and figure out that there are 60 squares here. And then we could do 3 times 5 and figure out that there are 15 squares there. And then from there, we can do 60 plus 15 to get the answer 75. So this is one of the strategies that we use to do multiplication when we're talking about like 2-digit or 3-digit numbers. And we could do the same thing with division. I could take 75, and if I wanted to take 75 and say divide it by 3, what I could do is I could take the 75 and I could break it up into things that I know are divisible by 3. So 75 is 60 plus 15, and then from there, I could do the 60 divided by 3 and get the 20, and do the 15 divided by 3 and get the 5, and find that my answer is 25. Multiplication and division are really the same process forwards and backwards, so we can use that to our advantage. The same thing is going to be true for polynomials. So this is 3 times 2 times 10 to the power 1 plus 5 times 10 to the power 0. We're thinking about those base 10 numbers all the way back from the exponents and powers unit. Well, again, we kind of made a connection from when we were doing algebra tiles to these powers of base 10. So this 3 times 20 and 3 times 5 is actually the same process we're going to do when we want to multiply polynomials. So if I took this polynomial, negative 2m plus 4, and I wanted to multiply it by 3, what I have to do is I have to take this 3 and I have to multiply it into both terms inside that polynomial. And I can do that in a couple of different ways. I could do it by using my algebra tiles, because what is 3? Well, it's telling me the number of groups. So all I need to do now is take my negative 2m plus 4 and write it out 3 times, and then from there add it up. So we have negative 1, 2, 3, 4, 5, 6m, and we have 4, 8, 12, 1. So negative 6m plus 12. But alternatively, what we can do is we can take this multiplication and we can split it up. We can say 3 times negative 2m plus 4 is 3 times negative 2m, which is negative 6m, and it's 3 times 4, which is 12. Question B, same thing. If I wanted to do this by using my algebra tiles, it is a little bit trickier because of that negative, but we take that negative n squared plus 2n minus 1, and we multiply it by negative 2 by first multiplying it by 2. So we'll write it down 2 times right here. But then because the 2 is negative, then we multiply the negative n as well, and all that does is it flips the color. So these negatives becomes positives, and these positives become negatives. So now, if I have this, I can add them up, and I see that I get 2n squared minus 4n plus 2. Alternatively, if I wanted to do this multiplication just algebraically without the algebra tiles, again, what I do is I take this whole term, negative 2, and I multiply it into all 3 terms inside my polynomial. So we get negative 2 times negative n squared, and negative 2 times 2n, and negative 2 times negative 1. And when I do that multiplication, I get negative 2n squared, negative 4n, and plus 2. So there's my answer. And going backwards is the same thing. If I wanted to do a division, I'm going to do it exactly the same way. Again, I can use algebra tiles. I can take my algebra tiles, my 4s squared minus 8s, minus 8, so 4s squared, 1, 2, 3, 4s squared, right, minus 8. So 1, 2, 3, 4, 5, 6, 7, 8. And to divide this by 4, what it's asking you to do is it's asking you to arrange the tiles into 4 equal groups, right? So I have 4s squared tiles, and I have my 8 negative s tiles that I can split up into 4 groups of 1s squared and negative 2, right? So that's my solution, s squared minus 2. Now, method 2, just like with the other one, is how we do this by avoiding the tiles. Because again, multiplications and divisions work very much the same way. So what I can do is I can take this polynomial and I can write it as 2 fractions. I can take my 4s squared and I can divide that by 4. And I can take my negative 8 and I can divide that by 4. So I get 4 divided by 4 is 1, s squared, and negative 8 divided by 4 is negative 2. Right, so either way, I get the same answer. I get s squared minus 2, but in 2 different ways. Question B, I could do it exactly the same way. I could use my algebra tiles. Now the problem with this one, again, because I have those m's and n's, it gets a little messy. But if I use my method 2 here, I see I get negative 3m squared divided by a negative 3. And then I get my 15mn divided by a negative 3. And I get my 21n squared divided by negative 3, right? So anytime I see negatives over a negative, it turns into a positive. So 3 and 3 turns into 1. So I get m squared. Positive 15 divided by negative 3 is minus 5mn. And negative 21 divided by negative 3 is plus 7n squared. Okay, so if I want to multiply or divide a constant into a polynomial, I simply do that by taking the constant and multiplying it or dividing it into each term of the polynomial. Now, if I want to do the same thing, but instead of it being a constant, I have a monomial, right? I can do that exactly the same way, but I just have to make sure I understand how x's multiply with x's. That's the only thing that's going to be different here. So same thing, if I have 2x and I want to multiply it in to my bracket here, I can do that by doing 2x times 3x and then 2x times 4. And then 2 times 3 is 6. Now this is the different part, x times x. Well, we kind of already know what x times x is because if we think about it as an x by x shape, what have we classified that shape as? Well, that is x squared. And if we think about it in terms of our powers and exponents, this is x to the 1 times x to the 1. And how do we multiply 2 powers with the same base? We add their exponents. So 1 plus 1 is 2. And then this is just a constant times my 2x, so we get 8x. Same thing with the negatives, doesn't really matter. I can take this thing and I can multiply it in, so I get negative 2x times negative 3x plus negative 2x times 4. Negative 2 times negative 3 is positive 6x squared, and negative 2 times 4 is minus 8x. So even if I have variables in my product, I can still do that as long as I understand how x's and x's multiply. Notice that when I'm doing these multiplications, I'm almost doing them in 2 steps. I'm saying 2x times 3x, so I do the 2 times 3 to get the 6, and then I do the x times x to get the x squared, right? I could do this exactly the same way using my algebra tiles as well. I need to set it up as a rectangle. So if I wanted to do that, I could do 2x times 3x plus 4. And then simply just look at the shape that's formed. So this inside is an x by x, so an x squared shape. And this is x by 1, so each of these turn into x's. And if I do it that way, I see that I get 1, 2, 3, 4, 5, 6 x squared, and 1, 2, 3, 4, 5, 6, 7, 8 x. Right, I get the same answer, but I get it in a pictorial way. Division works exactly the same way. The only difference here is we have to be thinking about dividing variables, right? So if I have negative 10m squared, well, m squared is m times m, and if we divide that by 2m, well, we can think about this as how does negative 10 and 2 divide? Well, they leave us with negative 5. How does m and m divide? Well, anything divided by itself always turns into 1. So we say they cancel, but they cancel because they divide each other away, and it just leaves me with negative 5m. Okay, part B here, same thing. I can break this up into two different divisions. So 30k squared divided by negative 6k. And then to that, we get minus 18k divided by negative 6k. So again, this is 30 divided by negative 6, which is negative 5. And k squared is k times k. And then when I divide that by a k, again, those 1k from the top and the bottom will divide out and leave me with 1, just like they did in the previous question. So I'll be left with negative 5k. And then minus 18 divided by negative 6. So we get 3. And then k divided by k. Again, they cancel and give us 1. So we're simply left with negative 5k plus 3. All right, well, that is it for the polynomials unit, and I will see you all in the final unit of the course.